Hello friends, in today's question, a simple pendulum of length L and mass of the bob M is oscillating in a plane about a vertical line between the angular limits -5 to +5 for an angular displacement of theta which is less than phi. The tension in the string and the velocity of the bob are T and V respectively. Then we have to find out which of the relations is true. So we have a pendulum which is suspended from this point. Let us suppose this is the mean position and it is oscillating between -5 and +5. So let us draw, this is our -5 and we have other extreme position, this is our +5, and it is given that for the angular displacement of theta, so let us draw the angular displacement of theta which is less than phi. So this is the angular displacement of theta, so this angle is theta, and at this position it is given that there is a tension T and velocity is V. So here we can divide this into two components, mg, and we have, this will be our theta, so we have this as mg cos theta and this will be mg sin theta. So let us find out what are the various forces acting at the bob. So this is our bob. So net force on the bob, net force on the bob, let us call that as F net, will be equal to T minus mg cos of theta, and this net force will be providing the necessary centripetal force. You can see this net force will provide the centripetal force. Which is, let us suppose, given as Fc, and Fc will be given as mv square upon L. Therefore, we can say that our F net is equal to Fc. F net is equal to Fc substitute the values, mg cos of theta is equal to mv square upon L. So this is the first relation, and from the figure it is going to have two accelerations, one with the acceleration along the tension and another one will be the, you can say, tangential acceleration. Okay. Therefore the tangential acceleration, if it is given as by at, then we can say that our mat will be equal to mg sin of theta. M and m cancels out, so we get tangential acceleration is equal to g sin of theta. So these are the first and second. So we have two relations to be true. Equation 1 and equation 2 are the two relations which hold rather good under the given condition. Under the given conditions. So this completes the question. Thank you.